Okay, we're going to have a quick look at this then. Okay, let's change colour. Right, so we should know to rationalize the denominator means make the bottom a rational number. The way to make root 7 a rational number is to times it by itself. Whatever you do to the bottom, you have to do to the top. And so you get 3 root 7, and root 7 times root 7 is 7. Okay, so we're going to get a lot of questions like this. Just as you would do normal fractions, you have to make a common denominator. The common denominator is going to be 6. So to get the first one out of 6, we've got to times top and bottom by 3. So times everything at the top by 3. Just like when you multiply out brackets, times everything in this one by 2. Now it's all out of 6, and I can, because it's a common denominator, I can add across the top. Add 2x, add 6, which altogether gives me 5x's plus 8 all over 6. Just check there's no common factors, which there aren't. So that's your final answer. Same thing here, except the common denominator is going to be these two things multiplied together. So the common denominator is going to be x times x minus 2. You got a minus this time as well, which will make it harder. So you got times top and bottom by x to get to x times x minus 2. So 4 times x is 4x. And you got times top and bottom by 2 minus x. So here you have to use brackets. Now combine it all. So that's 4x minus 3 bracket 2 minus x all over x minus 2. Now the bottom you can't really simplify any further, so there's actually no need to multiply the brackets, but the top you can. So do it carefully. Minus 3 times 2 is minus 6, but minus 3 times minus x is plus 3x. And so your final answer is going to be the 4x plus the 3x, which is 7x's minus the 6 over, and the bottom you could multiply out to x squared minus 2x if you wanted to, but there's no need. Okay, I'm going to show you a way I like to do this one. So if you use BIDMAS, you're saying, let's start with k, let's cube it, let's add 1, and then divide by 4, then you got your k cubed plus 1 over 4, and then what you've done, you've square rooted it to get to what they've got. And they're saying that's equal to m. So let's start with m and undo every step. So undo the squares, square root, so we square, so that's m squared. Undo the so I've undone that. Undo the divide 4 times by 4, it's 4m squared. Undo the add 1, so subtract 1. Then undo the cubing, which is the cube root. And that way, we must have got from m back to k. If you want to do it in a more traditional way, I'll do it quickly here. You undo in these steps, so it'd be m squared equals k cubed plus 1 over 4. 4m squared equals k cubed plus 1. 4m squared minus 1 equals k cubed. And the last step would be that one. So either way works. But this might be easier to understand as a way of explaining, but this might be better to write in the exam. But that would be acceptable in the exam also. The steps are clear. Okay, similar thing here. The common denominator is going to be b times a minus b. So times top and bottom by a minus b. So use brackets. Times top and bottom by b. Okay, so add across the top. Again, you don't have to multiply out the brackets at the bottom. So multiply out this bracket. 3 times a is 3a minus 3b add 2b. And so we can just collect like terms at the top. That's 3a minus 3b is at 2b is minus 1b, which is just written as minus b. Okay, for these, what you can't do is divide by x because there's no x here. So when you can't divide by a single factor, a number or letter, the only other option is to factorize. So if you factorize the top, hopefully you can spot there's a factor of 3x in both. There's a factor of 3 in both, factor of x in both. So if you take 3 and x out of that, you're just left with x here. And this, if you take 3 out of that, you're left with 2. If you take x out of that, there's no x's left. We're going to factorize this one, and basically the clue is that this is going to be one of the factors. So we're looking for two numbers that times to make 2, positive 2, and multiply to make minus 8. I know, I can pretty much guess that's going to be one of the factors. So I'm going to put a minus 2 in here. So that should be add to make minus 2 times to make minus 8. So that should be a 4. And if we try it out, yep, that works. So it's x plus 4, x minus 2. They cancel because you can divide top and bottom by the x minus 2. So it's just 3x over x plus 4. And you can't simplify that any further. Okay, here I recommend, remember this means multiply the bracket by itself, I recommend the grid method. It's got 5 minus root 5, and then 5 minus root 5. So multiplication grid, 5 times 5 is 25. 5 times minus root 5 is 5 minus 5 root 5. Same thing here. Minus and a minus make a plus. Root 5 times root 5 makes 5. Collect like terms. Well, there's like terms in this diagonal. 25 over 5 is 30. There's like terms in this diagonal. Minus 5 root 5 minus 5 root 5. So that's like minus 5x minus 5x, which would be minus 10x. So here it's going to be minus 10 root 5. Okay, we're going to do a really similar thing here. So I'm going to do this by the grid method, the top. And then we'll show you a shortcut method. But let me just do this first. Root 5 times minus root 5 is minus 5. So diagonal gives me 31. And if you notice this diagonal, plus 6 minus 6 root 5 just cancels, just 31. And the way you could have got to that quicker is to spot that that's of the form a minus b, a plus b, which is a difference of two squares. So it's just that square take away that square, which is 36 take away 5. Either way, you get 31 at the top and root 31 at the bottom. It says in its simplest form, so you should rationalize the denominator by timesing top and bottom by root 31. And then you get 31 root 31 over 31, which cancels down to just root 31. Again, quite a challenging one here. So let's just sort out this fraction down here. The common denominator is going to be root 2, so times top and bottom by root 2 here. So that can be written as 1 over 1. And then you get root 2 plus 1 over root 2. We should always try and rationalize the denominator when we can. So put brackets in there. Root 2 times root 2 is 2, plus the root 2 times 1, all over root 2 times root 2, which is 2. And then that can go in the place of that. So now we've got 1 over this whole fraction, 2 plus root 2 over 2. And obviously, to divide by a fraction, the same as timesing by the reciprocal, so that would be 1 times the reciprocal of that, which is obviously just the reciprocal. Then what we do with this is, to get to the final answer, we rationalize the denominator now. And to rationalize the denominator for this, we times by what we call the conjugate, i.e. we just use a difference of two squares. So if I carry on here, this is a difference of two squares, so it's going to be 2 squared minus root 2 squared, which is 4 take away 2, which is 2, so it's over 2. 2 times 2 is 4, minus 2 root 2. Everything divides by 2, so you're left with 2 minus root 2, which is what you wanted. Okay, again, nice easy one, times top and bottom by root 2, so you're going to get 5 root 2 over 2, that doesn't cancel down. Here, we can use a grid method to multiply out the brackets. I'll do each one separately. It's 4 plus 2 root 3 plus 2 root 3 plus 3. So altogether, that one gives me 7 plus 4 root 3. This one is going to be really similar to the other one, but we'll just quickly work through it. 4 minus and minus makes a plus, and you still get a 3, but this time you get minus 2 root 3 minus 2 root 3. So this one makes minus, and I'll put it in a bracket because it's a minus, 7 minus 4 root 3. And now if you concentrate on what's here, that's 7 plus 4 root 3 minus 7. Minus and a minus makes a plus. The 7 take away 7 goes. 4 add 4, it's just left with 8 root 3. Okay, so these, you can see it's a hard one. Prove algebraically that the difference between the square of any two consecutive integers is equal to the sum of the two integers. So consecutive integers, well, if we call one of them n, consecutive means the one next to it, so we'd have to call that n plus 1. Let's follow the instruction. The difference between, so that's subtract, so let's do the difference between the two numbers squared, which is going to be that. n plus 1 squared, I'll leave you to do that, but that would be n squared plus 2n plus 1 if you multiply that to brackets. Take away n squared, well that makes just 2n plus 1. And then the sum of the two integers, so the sum would be n plus 1. That makes 2n plus 1 as well. So you've shown it. You've shown that n plus 1 squared minus n squared is the same as n plus 1. The difference between the square of two consecutives is equal to the sum. Okay, this one's more of a direct proof, so we're just going to have to work this out. Again, quickly do the grid method. 2n plus 3, 2n plus 3, it's 4n squared plus 6n plus 6n plus 9. So altogether that one is 4n squared plus 12n plus 9. The other one's going to be the same but with minuses, so I'm just going to cheat and rub out. You could do it if you're using a pencil as well. The only thing that would change is it'd make that a minus 6n, that a minus 6n. That would still be a plus 9. So take away 4n squared minus 12n plus 9. So that's 4n squared plus 12n plus 9 minus 4n squared. Minus and a minus makes a plus 12n. Minus and a plus makes a minus. That cancels with that. That cancels with that. You're left with 24n. You want to show it's a multiple of 8. Well, that's 8 times 3n. So it's 8 times an integer. So it's a multiple of 8. Okay, again, it's all about factorization. If you take this one, hopefully you can see 3 comes out of that. So this fraction becomes 3 bracket x plus 2. Factorize the bottom one. And again, you can always do that thing where you guess. Because the x plus 2 is there, you kind of know it's going to be at the bottom. But anyway, you've got times to make minus 10. Add to make negative 3. Let's see if the 2 works. That would have to be a minus 5. That would be after minus 5. Hey presto, it works. So that's x minus 5, x plus 2. Now dividing by a fraction is the same as timesing by the reciprocal. And if I factorize this, I get x squared minus 25 over x plus 5. Well, on this side, I can do that. So that's 3 over x minus 5. On this side, you have to spot that this is a difference of two squares. So you get x minus 5 times x plus 5 all over the x plus 5. Well, that goes with that. That one cancels out with that one, so you're left with 3 times x. It's quite a difficult one. Okay, inverse functions. So think f's a number machine, and what it's telling you to do is start with x, times by 4, take away 1, and that's your output. But what we want to do is, we want to get back to the original. So let's start with x this time, undo the steps, so add 1, divide by 4, and then we'll get back to the original. So that must be the inverse function, x plus 1 all over 4. Second one, f of g of 2 equals 12. Work out the value of g. So f of g means put g of 2 into f of x. So we're going to do f of g of 2. Now g of 2 would be k times 2 squared. So that makes f of 4k. And if we put 4k into f, we just replace that x with a 4k. So that makes 4 times 4k minus 1, which is 16k minus 1. They're telling us the answer to that is 12. And so 13 equals 16k, and k is going to be answer to 13 over 16. Okay, yeah, and that's your lot. Hopefully, I haven't made any simple errors, but you should get a good idea of the methods from that video.